Now that you guys are familiar with balancing chemical equations, it's time to learn the different types of chemical reactions. So we're going to move into section 2, classifying chemical reactions. What we need to learn from this section is how to classify the different types of chemical reactions and identify the characteristics of the different classes of chemical reactions. Remember that a metal is an element that is solid at room temperature, a good conductor of heat and electricity, and is generally shiny. The new vocabulary that we have for this section: a synthesis reaction, a combustion reaction, decomposition reaction, single replacement reaction, double replacement reaction, and precipitate. Main idea for this section: that there are 4 types of chemical reactions: synthesis, combustion, decomposition, and replacement. All right. Chemists classify reactions in order to organize the many different types of reactions. The first one we're going to talk about is called a synthesis reaction. When I hear of the word synthesis, I think of a synthesizer, the instrument that plays music. Well, synthesize means to make. So a synthesis reaction is a reaction in which 2 or more substances react to produce a single product. Here is an example of a synthesis reaction. You have 2 elements, you have sodium and you have chlorine, and this up here is a balanced equation. Okay, every time you see an equation now, you should look at it and make sure it's balanced first. But we are taking sodium and chlorine and we're putting them together to make one product. Okay, so this is a synthesis reaction. A combustion reaction is when oxygen combines with a substance and releases light in the form of heat and light. Combustion to me means fire, breaking out into fire. When something combusts, it starts to burn, so you can think of it as that as well. Heated hydrogen reacts with oxygen to produce heat and water in a combustion reaction. Okay, this is also considered a synthesis reaction. You're making a product, but water and oxygen are going to be involved. Okay, in this particular case, you have hydrogen coming together with oxygen to make water. Okay, decomposition, to decompose, means to break down. So in this reaction, a single compound breaks down into 2 or more elements or new compounds. Decomposition reaction often requires an energy source such as heat or light or electricity. You have to input energy for something to break down. And then we go into what they call the single replacement reaction, or the replacement reactions, excuse me. There are 2 types. There's a single and a double. So a replacement reaction is a reaction in which the atoms of one element replace the atoms of another element. Okay? When one element changes places, it's called a single replacement. So in this case, you can see you have A plus Bx in the reactant, and that yields Ax plus B in the product. You can see that the A and the B have switched places. They have replaced each other. Sometimes these are called displacement reactions, so you can either hear single replacement or single displacement. Okay, a metal will not always replace a metal in a compound dissolved in water because of differing reactivities. So it's a good idea to have an activity series chart to be able to look at it to see which elements are more reactive. If it's towards the top of the list, it's going to replace anything underneath it. So lithium will replace any on this list. Lead will replace anything below it, but nothing above it. So lead could not replace magnesium. Lead could not replace rubidium, but lithium can replace anything underneath it. Okay, halogens work similarly. Halogens frequently replace other halogens in replacement reactions. Halogens also have different reactivities and do not always replace each other. So go back, I'm going to go back to the chart here and you can see at the bottom, okay, remember the halogens are in the column on the periodic table and these are all in the same column. And you can see that fluorine is the most reactive. Okay, fluorine will replace chlorine and bromine and iodine. But iodine will not replace any of those because it's on the bottom. It is the least reactive. Okay, so if they're on the top, towards the top of the list, they'll replace everything underneath it. Okay, so let's go ahead and go forward. So let's talk about double replacement reactions. Okay, these occur when ions exchange between two compounds. So instead of one element changing places, you're going to have two elements that are changing places. So in this top one, you can see you have AX plus BY, which is going to yield AY plus BX. You can see that the X and the Y have changed places. So here is an example that is written out for you. So you have calcium hydroxide plus HCl is going to yield calcium chloride. Okay, so the hydroxide has moved to go with the hydrogen and the chlorine has come over to combine with the calcium. So you have calcium chloride plus water. A solid product that is produced during a chemical reaction is called a precipitate. And we will look at this when we start doing our labs. So anything solid that is formed on the bottom of the tube or in the tube is going to be called a precipitate. All double replacement reactions produce either water, a precipitate, or a gas. Okay, this table shows the steps to write double replacement reactions or double displacement reactions. Okay, number one, write the component of the reactants in a skeletal equation. Remember, before it's balanced. Identify the cations, remember the positive ones, and the anions in each compound. Pair up each cation with the anion from the other compound. Write the formulas for the product using the pairs from step 3. Write the complete equation for the double replacement reaction, and then make sure that the equation is balanced. And you guys are really good at balancing equations now. Okay, this table summarizes different ways to predict the product of chemical reactions. Okay, so if you have a synthesis reaction, you're going to have 2 or more substances as reactants. You're going to have 1 compound as your product. And then you're going to have something similar to A plus B yields AB. If you have a combustion reaction, it's going to be a metal and an oxygen, a nonmetal and an oxygen, or a compound and an oxygen. Possible products, oxide of the metal, the oxide of the nonmetal, or 2 or more oxides. And you're going to have A plus O2 yields AO as an example. Decomposition, remember it's going to break down. You're going to have 1 compound as the reactant. It's going to break down into 2 or more elements. And an example would be AB yields A plus B. Single replacement reaction, also called single displacement reaction. You have a metal in a compound or a nonmetal in a compound. And you have, for the product, a new compound and the replaced metal, or a new compound and the replaced nonmetal. You're going to have A plus BX is going to yield AX plus B. Double displacement or double replacement reaction. You have 2 compounds as your reactants and your products, 2 different compounds, one of which is a solid, a water, or a gas. Okay, an example, AX plus BY yields AY plus BX. And the answer is And the answer is